So the last example just showed us how piecewise defined functions, remember, can lead to limits which don't exist. I said earlier that that is one way that we can see limits that don't exist. Another way that we can come up with limits that don't exist are in rational functions here. Something like g of x is equal to 5 over x plus 6. So let's use the numerical and graphical approach to find the limit when x is going towards negative 6. Now you can see the problem here. If I plug in negative 6 into the function, this negative 6 in the denominator is going to cause my denominator altogether to be 0. So that's going to give me a problem. So let's actually do this. Let's do this numerically and then graphically. So what are we going towards? We're going towards negative 6. Let's go from below, negative 6.1, 6.01, negative 6.001, and then from above, negative 5.9, negative 5.99, negative 5.999. Okay. And we can type this in to g of x. So let's go ahead and do that. So negative 6.1, just type that in. Negative. I ended up with a negative 50. Negative 6.01, type that in. I ended up with a negative 500. Negative 6.001, type that in. I ended up with a negative 5,000. We know if you plug in negative 6, it doesn't exist. How about going from above now? 5.9, you type that in, and you get a positive 50. Negative 5.99, you type that in, you get a positive 500. And negative 5.999, you type that in, you can guess what we're going to get, 5,000. Notice that we are not converging to different numbers. In fact, as you go to negative 6, this side's just getting bigger and bigger and bigger in the negative sense. It's getting going towards essentially negative infinity. And this side's going bigger and bigger and bigger in the positive sense. So they're not converging to a single number. And therefore, we would say it does not exist. Now, what were to have happened if, for instance, these were all positive? So we got positive 50, 500, 5,000. Would we still say it doesn't exist? Well, there's no real number that our limit is equal to. We will find out in subsequent sections that if we get a situation like this, where both the left-hand side and the right-hand side force me to converge, and it just keeps getting bigger and bigger, we can call this infinity, this limit infinity. But for right now, we'll just say there's no real number that exists that this is converging towards. Let's graph this and see what it is. We would go y equals 5 divided by x plus 6. All right, I got to zoom out a little bit, move things over. You can see what's happening. As we're approaching negative 5 on the left, our graph is shooting up. Did I say on the left? I'm sorry. On the right, our graph is shooting up and just going way, way up there. And as we're approaching negative 5 from left to right, our graph is shooting way, way down here, right? And therefore, we're going, oops, did I say negative 5? Negative 6, I'm sorry. As we approach negative 6 from left to right, we're going down. As I approach -6 from right to the left, I'm going up. So that's what's happening graphically. We're not meeting up at a certain point. Now, what I'd like you guys to do is I'd like you to try these two rational functions. And I want you to try numerically to get limits here.